For decades, TON 618 reigned supreme, the monster of monsters, the heavyweight champion among black holes. A cosmic abyss so massive we struggled to imagine anything larger. But then, astronomers found something even bigger. A black hole so enormous, so terrifyingly massive that it forces us to rewrite the limits of cosmic physics. Phoenix A, the largest black hole ever discovered, weighing in at around 100 billion solar masses. This thing doesn't just break records, it obliterates them.
Meet Phoenix A, the most massive black hole known to science. Before we face this cosmic titan, let's understand what a black hole actually is. A black hole is a place where matter collapses into such a tiny volume that gravity becomes unstoppable. Not even light escapes. At the center lies the singularity, a region where density becomes effectively infinite. Around it is the event horizon, the point of no return. Black holes form when massive stars collapse, but the true giants, the ones tens of billions of times more massive than our Sun, must grow through galaxy mergers and the violent feeding of gas, dust, and even other black holes. Black holes are not rare. Our Milky Way alone is estimated to contain over 10 million. Spread that across hundreds of billions of galaxies, and the universe may contain trillions of black holes. But among all these, only a tiny handful become ultramassive. Most large galaxies have a supermassive black hole in their center, millions to billions of solar masses. But ultramassive black holes? Those reach tens of billions of solar masses. Their formation is still a mystery. And then there's Phoenix A, a black hole so massive it challenges everything we thought possible. Phoenix A sits at the heart of the Phoenix cluster, around 5.7 billion light-years away. Its mass is estimated at around 100 billion suns, making it the largest black hole ever found. To put that into perspective, Phoenix A is over 2 times more massive than the entire Triangulum galaxy, far heavier than TON 618, 66 billion solar masses. So large it could swallow our entire solar system and still have room to spare. Scientists believe its event horizon may exceed the orbit of Neptune. This thing is not a black hole, it's a cosmic vacuum cleaner with no off switch.
TON 618 has long been the internet's favorite cosmic terror, and for good reason. Its mass is around 66 billion suns, and it sits in a hyperluminous quasar. But Phoenix A absolutely dwarfs it. This is the moment TON 618's crown passes on. A new king has risen.
Black holes can't be seen directly, but Phoenix A reveals itself through X-ray emission from surrounding hot gas, the motion of stars in its galaxy, gravitational effects on the Phoenix cluster, incredible energy output from active regions around it. Signs also point to the cluster undergoing multiple galaxy mergers, feeding Phoenix A over billions of years. Black holes can't be seen directly, but Phoenix A reveals itself through X-ray emission from surrounding hot gas, the motion of stars in its galaxy, gravitational effects on the Phoenix cluster, and incredible energy output from active regions around it. Signs also point to the cluster undergoing multiple galaxy mergers, feeding Phoenix A over billions of years.
Before Phoenix A, scientists believed black holes had a practical upper limit of around 50 billion solar masses. Then, Phoenix A comes along at 100 billion and says, let's double that. This discovery forces astrophysicists to rethink
how fast black holes grow, how galaxies evolve, how matter behaves under extreme gravity, whether even larger black holes exist beyond our observational horizon. The first confirmed black hole, Cygnus X1, discovered via X-rays in 1964, was tiny compared to these giants, only about 21 solar masses. But it changed everything. Stephen Hawking and Kip Thorne even made a friendly bet about whether it was a real black hole. Hawking later admitted defeat when evidence became undeniable. Cygnus X1 was the first glimpse into a much darker universe. Material spiraling into Cygnus X1 heats up to millions of degrees, emitting powerful X-rays, essentially screaming, "There's a black hole here." This method still helps us identify black holes today, including those in distant clusters. Back home, Saturn's rings are shrinking. Over millions of years, gravity and solar radiation slowly pull the icy particles inward. They're stunning, but they won't last forever. Earth could have rings, but the Moon's strong gravitational influence would tear them apart. We're simply in the wrong neighborhood for a stable ring system. Now that we've journeyed across scales, from Earth to Saturn, Cygnus X1 to TON 618, we return to the cosmic king, Phoenix A, the largest black hole ever discovered. The one that shatters everything we thought we knew. A black hole that could swallow galaxies whole. And remember, if we've already found something this big, what giants still lurk beyond the universe we can see? If you enjoyed falling into cosmic madness with me, hit like, subscribe, and turn on notifications so you never miss our next dive into the unknown. There's much more out there, and together, we're going to explore all of it.